All right, well, hello everybody. We're going to learn about limiting reactants. So I like to abbreviate them as LR, and we'll show them in just a second. So a limiting reactant is the reactant that limits the amount of product produced, okay, by a chemical reaction. This is the reactant that will be completely consumed during the reaction. Completely consumed. When the limiting reactant runs out, the reaction will stop and no more product will be formed. The excess reactant is that other reactant that does not completely get consumed during a reaction, so you have some of it left over. So, for example, if I'm making a sandwich, for my sandwich I need meat, cheese, and bread. And so if my wife went to the grocery store, she bought a loaf of bread, and she bought just some amount of meat and some amount of cheese. If I like my meat, and so I put too much meat on the sandwich every time, and I end up running out of meat. Right? Well, I can't make any more sandwiches anymore. Right? Even though I have excess bread and I have excess cheese, my meat was my limiting reactant. So that's essentially a good way to introduce it. So a limiting reactant problem is the way you can identify them is that limiting reactant problems always have two amounts. They have amounts of two different reactants. You either have they're either both moles or they're both grams or whatever, but you have two different things and you have amounts for both of them. You're going to run out of one first, and so that's the goal. We need to figure out which one it is. So the limiting reactant is the reactant that will produce the least amount of product. And that's actually what we're going to look for. That's how we're going to identify that, is the least amount of product. So we're going to pretend that they both went to completion, and whichever one's the lesser amount is going to be your limiting reactant. So for example, we have, if we're given a chemical equation, aluminum plus hydrochloric acid makes aluminum chloride plus hydrogen gas. If 3.2 moles of aluminum react with, let's say 3.2 moles, reacts with 10.1 moles of HCl, which reactant is limiting? Well, you have amounts of both of them. You're going to run out of one first. It's not always the lesser one, though, okay? Because sometimes they're because you consume them in different rates. Remember, you're consuming 2 moles of aluminum for every 6 moles of HCl. So it's not just always the lesser number, and it's usually a trick. Okay, so be careful. What we're going to do is we have to find 3.2 moles of aluminum here, and then we're going to see how much product it makes. Well, we're going to just convert it to the same product. So we're going to convert moles of aluminum to moles of hydrogen this time. Maybe hydrogen might be easier. So for every 2 moles of aluminum, it will make 3 moles of hydrogen. And so we get 4.8 moles of hydrogen. Okay, so let's try that other one. Let's do 10.1 moles of HCl. And let's change moles of HCl into moles of our same product. Okay, the same one. And so we're going to, for every 6 moles of HCl, 3 moles of H2 will be produced. So we end up with 5.05 moles of H2. So you end up with 2 amounts of H2. The lesser amount, that would be this guy, is going to be your limiting reactant. So this guy is your limiting reactant. Hydrogen is not your limiting reactant. Okay, a lot of people see 4.8 and they think, oh, I'll just pick this one. No, remember hydrogen is a product, okay? One of these guys is going to be the limiting reactant because it has to be a reactant, right? So aluminum is the limiting reactant. So what I like to do is cross out the one that is in excess because we are not going to use it in calculations. It is useless, okay? You always use the limiting reactant for your stoichiometry calculations. Okay, so how many moles of H2 are formed? Well, we just found that out. That's 4.8 moles of H2. Okay. How many moles of the excess reagent remain after this reaction? Okay, so that's interesting. We know that we started, let's see, of our excess reagent. So our excess was this guy right here. We started with 10.1 moles, and this is how much we had available, right? And we consumed a certain number of moles. Now, how many moles was that? Let's figure that out. We had 3.2 moles of aluminum. How many moles of HCl did that consume? For every 2 moles of aluminum, we needed 6 moles of HCl. So that ends up being 9.6 moles of HCl. Okay, so we consume 9.6 moles. That is how much we consumed. So if you take how much was available and how much you and subtract it by how much you consumed, we end up with 0.5 moles of HCl remaining. Okay? So you have to do that in moles. And that is, this is the real tricky one that messes students up. You always have to think moles of available minus moles consumed. All right, that's always the key. All right. Let's move on. Let's get a little more difficult. If we weren't just given in grams, we were given in we weren't given moles, we were given grams. So if we had 64.3 grams of nitrogen and reacts with 16.5 grams of hydrogen, identify the limiting reactant. So we have amounts of 2 different things. We're going to run out of one first. So let's see how much we would produce of ammonia. So we're going to start with 64.3 grams of nitrogen. And we're going to change grams of nitrogen into moles of nitrogen. The molar mass for nitrogen is 28. And then we're going to change moles of nitrogen into moles of ammonia. That's our product. There's only one product this time, 1 to 2. That's a 1 to 2 ratio. Coefficient is 1, coefficient is 2. It's a mole of ammonia to grams of ammonia. I need to go to the periodic table. Nitrogen is 14 plus 3, so that's 17. Okay. And then, so I find out that that would produce 78.1 grams of ammonia. And now let's try the next one, 16.5 grams of hydrogen. And grams of hydrogen into moles of hydrogen. So there's 2 grams per mole. And then I take moles of hydrogen into moles of ammonia. So we have 2 and 3. And then moles of ammonia. And the grams of ammonia. And 17 to 1. Okay, Well, do that calculation, and you end up with 93.5 grams of ammonia. So now you're able to identify which one is the lesser amount. That's this guy. Again, the first one. And you'll see that even though you started with 64.3 grams of nitrogen and you had more mass than this one, this is the one you ran out of first. So as you can tell, it's not always cut and dry from what you're given. So this guy is our limiting reactant. So if I ask you to identify the limiting reactant, please write down N2 is LR. You could say that. That would be fine. So this guy is our excess. We're going to cross it out. It's legible, but it's we know that we not to use it later. Okay, so how many grams of NH4 will be produced? That's going to be 78.1 grams of NH4. NH3, not NH4. Okay. How many grams of excess reagent remain after the reactants? Okay. So again, we're going to have to find grams available, and we're going to have to subtract it by the grams used to find the grams left over. Okay, the grams available is easy. That's given in the problem. We were given 16.5 grams of hydrogen. So that's going to be 16.5. Okay? And then we're going to have to subtract it by the grams used. Now we'll have to do a little stoichiometry magic to figure that one out. We need to figure out our excess reactant, our limiting reactant, 64.3 grams of nitrogen. And we need to do some stoich. I'm going to run out of room. And change grams of nitrogen into moles of nitrogen. It's 28. I regret doing it like this. Moles of nitrogen into moles of hydrogen. Because now I'm going from my limiting to my excess reactant. That's how you do this. Okay? Just go from your limiting to your excess now. And so your excess reactant is, that's a 3 and that's a 1. And then the next one, I need to change moles of H2 into grams, and so that's a 2 to 1. I barely got that in. And so we end up with 13.8 grams of hydrogen used. I'll zoom in just a little bit so hopefully we can see that if you're watching that on a tiny screen. So that's 13.8 grams of hydrogen used. So that means I use that. And then now just subtract the 2. And so we end up with 2.7 grams of hydrogen remaining. Now there are a few other ways to do this. Some people like to do those, but this is just one way to show you, and I think it's pretty consistent. All right, now check out that last one. This is your little this is your learning check. Go ahead and try to do this one on your own. After that, I'll show you the answer, and I'll also show you a little trick to do. Okay, the first step will be to identify the limiting reactant. So what you'll do, here's the trick. You have that many grams of calcium hydroxide. I have to write small. We're going to change grams into moles, just like usual. That's pretty standard. The mass of calcium is going to be 40. And the mass of oxygen is 16, and the mass of hydrogen is 1. So 40 plus 2 times 16 plus 2 is 74. And so stop there. we're going to do the same thing. We're going to find the moles of HCl. 96.6 grams of HCl. We'll change grams into moles again. And so 1 plus 35.5 is 36.5. 110 divided by 74, we get 1.49, okay, moles. And then for 96.6 divided by 36.5, and we get 2.65 moles. Now you still can't stop there. That's the moles of calcium hydroxide, and this is the moles of HCl. Find the number of moles and then just divide by the coefficients. So this coefficient for this one is 1, and so we still get 1.49. And then the coefficient for this one is 2. So divide that one by 2. 2.65 divided by 2 is going to be 1.32. Okay? Now, whichever one is the lesser one is going to be your limiting reactant. So this guy is my limiting reactant. Okay? That's how you identify that. Okay? So that it saves you the step, because if you noticed up here, it gets redundant at this point. You're basically dividing by the coefficient, but these calculations are going to be the same up here. So it's essentially cutting that part out. So just find the number of moles, divide by the coefficient, and the lesser number is your limiting reactant. So once we know that, now we can find, we said that there were 2.65 moles of HCl. Right? So now we can change moles of HCl. The only thing that's useful about this number is that it has, it just shows you the limiting reactant. We're not going to use this number. We're going to use this one. This is the moles of HCl. So the moles of calcium chloride, and so it's a 2 to 1. And then we need to find the grams of that. And so molar mass for calcium is 40, and then 2 times 35.5, and so that's 111. So our calculator work will be 2.65 divided by 2 times 111. And I'm rounding all over the place. This is not very exact. So we have 147 grams of calcium chloride. Okay, so that's one done. So let's do the other one. So finally we found the masses of each product. And we barely have enough room to find out how many grams of excess reagent remain. So now we need to figure out the excess reagent was calcium hydroxide. We started with 2.65 moles of HCl. Let's find how many grams that we used up. So moles of HCl into moles of calcium hydroxide. And so that is a 1 to 2 ratio. Let's find out how many grams they are. Moles to grams. I'm going to cut off the, and so we already found that molar mass. That's going to be 74. So 2.65 divided by 2 times 74 is going to be 98.05 grams of calcium hydroxide. That's how many was used. So we had 110 available. We're going to subtract it by 98.05 grams. And so we have 11.95 grams of leftover. Boy, that was fun. Welcome to Pre-AP Chemistry. All right, so that is all the calculations. That would be the hardest example to do, just because it requires so many little points to do. All right, have a great day.